Okay, so to conclude the day, we have the lightning talks session, the first one for the symposium. I will just ask the speakers to only grab the microphone by hand in order to optimize the context switch. Let me just also remind you that you only have 5 minutes for your talks. If you go beyond the 5 minutes, you will be shot. And let me also give you a little bit of explanation in terms of which signals I'm going to send the speakers. This is based upon a recommendation from Mark Evanson. So when I'm going to do this, it doesn't mean that you're doing fine. It means you have only 1 minute left. When I'm going to do this, it doesn't mean you're okay. It means you're dead. It means you have 0 minutes left. All right? So first in line is Nicolas Hafner.
Where's the microphone?
You just brought it back.
All right. Hello. My name is Nicolas Hafner. You might know me by my internet username, Chimera. I write a bunch of libraries and stuff. So last year I had a quick lightning talk about QTools, which makes using Qt from Common Lisp about neat, gives you sort of Lispy syntax to write it with, and eliminates all the annoying C++ stuff. Also takes care of garbage and all that. But I omitted a little detail, which is that Qt itself is awkward sometimes. Layouts are lackluster, some features can't be changed, and switches are not extensible enough in some cases or even wrong. And since, well, what can we do? Qt can't really feasibly be changed. We would have to deliver our own version of the library. There's no way to hack it in. Otherwise, it's written in C++. We access to the C wrapper called Smoke, which is also annoying. So what else can we do? Well, we need to rewrite it all, but this time in Lisp. Hooray! So that's QTools UI, which offers a new dynamic layouting protocol, which is focused on allowing you to shuffle widgets around and make dynamic changes on the fly. It implements a few standard layouts and widgets that you can use directly. It includes useful base classes to work with, and has a few pre-made components that you can just plug into your application straight away. So, for example, here you have a sort of panel list that you can detach and collapse stuff with. And, for example, you have a neat color picker thing, or you have a REPL that's fully working with printing and everything. And you even have a portable debugger that runs on every system that supports Common Qt. So, what's next? We need more layouts, more components, more everything. So also UI components are really hard to test. There's lots of edge cases. How are widgets scaled and so forth? What kind of preferences do you have? So I need help in testing that, and I need more contributors to actually add more features that you guys need. And yeah, if you're ever intending on working on UI stuff with Qt, you are very welcome to contact me or contribute stuff that you've already built and sort of tear it out. It's all separated into neat little components that you can load individually to only ever get what you need, basically. It's available on Quick Lisp. You can check it out. Thank you.
Next in line, Daniel.
Does that mean that the next speaker can take his time and giving you...
Yes, let's do that. It's going to cost us.
Hello. My name is Daniel Kochmański, and I want to tell you about my personal stance on contributing to the Common Lisp ecosystem. And yes, I'm aware that there are other Lisps, but I'm a Common Lisp programmer, and I believe that these advices may be mapped to the other implementations, other Lisps. So, the most obvious way to contribute to the ecosystem of Common Lisp is to create a library. And you have the eternal fame and everything. But there are a few problems with that because we have many libraries and sometimes people duplicate effort, and a new user of the ecosystem doesn't know which library to use. And there are some duties person who wants to write a new library has to take, because he needs to do state of the art. He needs to check what needs to be implemented, what is implemented, and it's important to write documentation, specification. It's really hard to write good code. And here we go to the second possibility, how we can contribute. We can improve existing software. We have many good libraries, and we can improve that. We can write documentation, we can test, we can cover corner cases, we can port it to the other implementations. We can teach the common Lisp, we can write tutorials, essays. We have in Poland, we have one scientific club about common Lisp. Soon we will have the second one. And I think it's really exciting. And sharing knowledge is really profitable because we have more programmers who write more libraries, who improve our libraries. Right. And we can get involved with existing implementations. We have many implementations of Common Lisp. Each has its own advantages. Ones are fast, the others are slow. But each will benefit from providing documentation, from testing them. And we can improve this compatibility with ANSI tests, so test grid. We have portability layers. The implementation has different extensions, and API is different. So if we use the portability layers like Bordeaux threads, a common foreign function interface, everyone benefits because somebody wants to use your library on his own system, and it works. And in my personal opinion, we have a few priorities. We have some, ISDF is de facto standard of system building today, and it's not specified, documented, and I think that this is a worthwhile effort. C-Lisp, Common Lisp doesn't have right now a maintainer, and let's go to the last one. We need to create a non-Emacs IDE for Common Lisp. Emacs is great, it's my editor of choice, but it's hard for newcomers. If somebody needs to learn Emacs and Common Lisp, it's really hard. And if you still doesn't know how to contribute, you may pass some money to the Common Lisp Foundation. You may write a song about Lisp. There is a few. If you have some project which you want to outsource, just hire Common Lisp hackers and learn the Common Lisp. Thank you for your attention. And if you have some questions, we don't have time, I believe, so please send it to my email. Presentation is accessible on this URL. Thank you.
Yeah. Next up, Jan.
It's not my talk.
This is the arrows.
Oh. Sorry. Okay, so this is an announcement for a job offer, temporary job offer. The money comes from an ANR project. The ANR is the National French Research Agency. So I am part of this Graphene project. Graphene stands for graph enumeration. So I have a project called TRAG, which stands for Term Rewriting Automata and Graphs, which is entirely written in Common Lisp. And I would like a web interface to make it available to the research community. I would like also possibly a database to store examples and information computed from examples submitted by potential users. So the work needs to be done using, the work could be done using Common Lisp or not, but it would be better if it's in Common Lisp because then I could work on it when the person is gone. So you need at least a master degree. There is a monthly salary which could be higher if the person has some experience. It's for 18 months. It can start as soon as possible, but should end before September 19, because this is the end of the project and we won't get any more money after that. So the skills required: programming, all paradigms, web programming and technologies, databases, and that's it.
We still have 4 minutes.
Yeah, I know, but I wasn't planning. Or if you are interested, or know someone that could be interested, please contact me.
Thank you. Andrew.
Where's my microphone?
Just grab it.
Okay, right. Next, I shall time myself. Okay, this is a cut down of what would have been a bigger presentation if they hadn't rejected me in the first place. So I'm going to be very quick. So in the last year, we at Ravenpack have been moving some stuff into the cloud. Big data is the buzzword. It means lots of infrastructure, which is expensive, difficult to manage if you're doing it yourself, and seems to be the future for the moment. We'll see how that goes. What do? We convert unstructured data to structured data for the financial industry, news and social media, which means tens of terabytes of data. And we used to have a big database. We still do for older products. Unfortunately, if you're classifying lots and lots of data, there's only a limited number of client applications that can connect and process simultaneously. You have one database server because all your data is in one place. You have problems, big problems. Amazon Web Services, where we're going, solves a lot of these problems. It's well documented, full of surprises though. The API is good, the behaviour is unpredictable in certain situations. Support, however, is good, especially if you get someone for yourself, but it is costly. The problem is classifying data. We have 20 years worth of data every time we have a new product. We have to reclassify everything. With the old DB, it would take 6 weeks to redo all the data for a new product, assuming no bugs are found. We have sometimes 3 weeks in found a problem. So that, and it also means the machinery necessary for this, we don't use it for anything else. That's idle 10 months a year. So in AWS land, we use a bit of everything. We've had to rewrite large parts of the system, but in Lisp, so it's pretty quick. And we've learned an awful lot. As I said, the APIs are well documented, but the behaviour is not in certain circumstances. So for S3, we've got Zach's S3 library, works really well. For everything else, we wrote it. I would like to publish it. I don't have the time to do so someday. But we have interfaces to DynamoDB, stuff like this. The good thing about this is it's almost all JSON. So that's sort of lists of things. And with a bit of CLJSON and other libraries, you end up really, once you've done all the wrapping, all the signing and stuff like that, all you're really doing is building lists and then converting it into JSON and sending it off to Amazon and getting a list back. And every single API looks a bit like this. It's nothing very exciting, but it works well and it works very reliably. So what do we end up doing? Hundreds of worker images running at once. Everyone having a full list system. There's a metadata database for stuff that gets loaded at startup. And it has a list of jobs to be done. We divide everything into hours over 20 years. These images just use transactional SQL to mark some sort of job as in progress. Use S3 and DynamoDB to get their data. And the whole thing scales very linearly because you are now using these Amazon services for the main data transfer and you don't have that central point of failure anymore. Result being, Lisp is great for interactive development. AWS, it was great. There's lots of JSON, so it's very easy to implement. And it's easily manipulated at the REPL. And we even do things like our AWS errors are all internal. We automatically translate them into Lisp errors. And a couple of buts. Things that make huge differences. HTTP Keep Alive, use it. It's often not on by default, but once you do, everything runs so much faster and the routers are, well, happier. It's a simple thing, easy to forget. Spot instances. In Amazon, you can reserve stuff, that's expensive, or you can bid for it. That's cheap. The trouble is, they take it away again when you least expect it, because someone else has more money than you do. That's inconvenient. So what do? There's multiple zones. Distribute your machines across the zones. The pricing tends to be zone specific, so when someone takes all the machines in zone A, you're still running half your stuff in zone B, you're okay. Make sure your machines start quickly because they take it away after 20 minutes. If you take 10 minutes to start up a machine, you've lost half your computing time. So we just build images, pre-prepared images. And DynamoDB, you have to manage all your throughput and permissions by hand, which is a major problem not yet solved because what we do peaks and troughs very quickly. So that's something we're still working on. We get away with it. It's not too bad. However, at the end of all of this, stuff runs faster. We don't need to go anywhere near a real-time system. We only pay when we need to do some work. And as I said, the hum of hundreds of Lisp servers can be heard for miles around, and it's lovely just to see it all working. That's 5 minutes.
Yes, well, we saved a couple.
Oh, yeah, right. We're always looking for people. If any of this sort of stuff interests you, send some CVs in. We might be interested. That's it.
You're dead.
I know I'm dead. Right.
Anton.
Hello. There is a belief that when you change your library API in an incompatible way, all you need to do to protect clients of your library from breakage is to upgrade a major version number. Just change the version major number from 1 to 2. That's not enough. For example, let's consider a dependency tree of an application which uses Hanchin-Tut and postmodern. We can see that many libraries are present in this dependency tree multiple times and are used by different client libraries. This fragment demonstrates that MD5 library is used by Hanchin-Tut and by CL Postgres. So if we imagine that we change MD5 API incompatibly, for example, change function parameters, and signal this just by upgrading major version number, and then we imagine that CL Postgres adopts new MD5 while Hanchin-Tut still depends on old version of MD5. Like this. Hanchin-Tut uses version 2 and CL Postgres uses version 3. Then our application becomes broken because it is impossible to load simultaneously two versions of the same library because they interfere via package name. Version 2 tries to load old code into this namespace, and version 3 tries to load new code into the same namespace, and they break each other. So that's in common Lisp. There are languages and package managers where this doesn't happen. Often in JavaScript package managers, there is no global namespace. But in common Lisp, we have this problem. So the main point, if we want to save our clients from trouble when we change our API incompatibly, we need to ensure the new version of our library can be loaded simultaneously with the old version. So in common Lisp, this means we need to give new package to the new version of the library. Like this, package can be named MD5 version 3. And another little nuance is that I feel that the notion of major version number is redundant and unnecessary. Because if this is a new API, it's a new thing, and we can give it a new name. So instead of writing major version number 2, we can just give our SDF system new name. And moreover, in common Lisp, it's the only suitable way today, because for major version numbers to work well, we need all clients to specify dependencies with the major version numbers. Not only new clients should specify version 3, but old client also need to specify version 2. And this doesn't happen in reality. People rarely do this. Also, Quick Lisp doesn't support several SDF systems different only by version number. And in my opinion, it's more in the spirit of functional programming to assign value to a name once and never change it. It becomes more stable. So, the conclusion. If we want to change library API incompatibly, then we need to ensure a new library can be loaded simultaneously with the old library. And in Common Lisp, this means new package for new library. And if our SDF system doesn't include the old API, it makes sense to give that SDF system new name. Or the best is to not break backward compatibility, because it's very often trivial to maintain backward compatibility. For example, instead of changing function parameters, we can leave this old function as it is and just introduce a new function. That's all, thanks.
Just one quick remark. An alternative to what you suggest would be to have Lisp systems implement first-class global environments, the way I suggested a couple of years back. And you wouldn't have any problem.
Maybe let's discuss with
Global environment. Alessio. Is it this? Oh. Oh, okay.
Okay. Okay. So everyone here knows Lisp is ultimately all about lists and symbols. Those are the things that set it apart, allowing macros and so on. So what are symbols? They are names for things. So they have a name, which is a string, which is used to read and print them. And they have properties, which can be built in, like value and function slot and so on, and user-defined properties. And so they have a name and many meanings. So early Lisps had a global namespace for symbols, but then people started loading different softwares in the same Lisp image, and that causes conflicts because the symbol with the same name would have incompatible meanings. So packages were introduced in Common Lisp, at least in its legacy. So they disambiguate between symbols. So you can have the same symbol named bar into different packages, foo and baz. So packages themselves have a name, which is a string. They have properties, like a list of exported and internal symbols and so on. And they live in a global map. So there is a single environment for packages, and they don't really exist outside of that environment. Because if you delete the package, it still exists as an object, but you cannot effectively use it. So nowadays, we have huge software built of several libraries, open source libraries, and also different versions, like the previous talk said. So we're starting again to have a problem. We include lots of different codes, and so packages live in the same namespace, and there is a risk of conflicts, especially with short nicknames. So do you notice a pattern? So one idea I had as an experiment is to conflate symbols and packages in the same data structure. So to have a symbol, a new type of symbol, which has a string name, properties, and can contain other symbols. So you can have a symbol baz inside the symbol bar, inside the symbol foo, inside the root. So I did it on ABCL in a way that maintains compatibility with ANSI Common Lisps. So packages continue to exist, but just as a facade over symbols. The root symbol is also the home of keywords, so the colon keyword syntax is a nice consequence. Packages are symbols in a special package, and it's too long to explain why. And the ANSI test suite has the same failures, so I'm quite confident it's ANSI compatible. Why I did that? Because, well, it appears to be a nice concept. I mean, it seems less pure, more pure with more or less concept. Those new symbols map nicely to hierarchical names like file names, so we could get rid of path names too, and also as a foreign language interface with languages with several layers of namespacing, like namespace, class member, and so on. As a bonus, you get a symbol aliasing operator, which is needed for nicknaming packages. As a negative side, delete packages becomes a problematic operation. But this is more comforting than I thought. So things to do, really verify that there are no non-conforming points with the ANSI standard, polish it, port it to other Lisps and verify if it was doable on ABCL because of some specificity of ABCL or if it's replicable, and hopefully standardize it with a specification.
Thank you. Up next, oh, it's me. Can somebody please shoot me if I go beyond the 5 minutes? Thank you very much. Yeah? Okay. I can see we have a lot of volunteers. So this is just a quick talk to announce the first release of a library called Focus. It stands for Format Customizations. I've actually talked about this already, I believe it was like 4 years ago, but I never got around to implement anything, but this time it's done. So the idea of this library popped up in my mind when I was developing Declet, which you may already be aware of. It's my library for generating reference manuals for ASDF systems. So in Declet, I have a lot of calls like the what's advertised on the first line, calls like format T tilde A escape str, and in that particular case, escape is a function which takes a string of documentation and properly escapes it for the TechInfo documentation format. Okay, and there are lots and lots of calls like this one in the Declet library. So obviously this is not very satisfactory to me, and I would have liked to be able to abstract this away, for instance, by using a custom format directive, as is demonstrated in the second line of code. For instance, I've chosen this one just at random, like tilde backquote, which would actually call the escape function. Okay, but unfortunately, I cannot do that because the format DSL is not extensible. Well, actually, it is to some extent. There is a special directive called /, which allows you to plug your own behavior into format. This is the third line. But the problem with this is that either the function that you want to call has to reside in the CL user package, or you are obliged to fully prefix it with the package name. Okay, so essentially, in my opinion, this makes the / directive completely unusable. It's actually longer than what you would do by calling the function directly. So that is where Focus comes into play. Focus is actually a wrapper around the standard format function. It's actually implemented as a macro for reasons that I will explain later. If you use Focus's format macro instead of the standard one, you have a completely programmable DSL, which is based on the standard format one, but that you can completely redefine. So you can add new custom directives, you can replace the standard ones, you can also reassign the standard directive to other characters, etc., etc. You can do everything that you want. It's also case sensitive, so you can have distinct directives for tilde A downcase or tilde A upcase, for instance. All of this is programmable in what's called a format table, and as you probably can guess by yourself, this is a data structure which resembles a lot read tables. Okay? This is where you store all your customizations. By default, the focus library behaves in a completely dynamic manner. This is to allow you for the utmost flexibility, and this is probably totally useless. Most of the time, you will probably have compile time fully defined at compile time format tables. So in such a case, you don't want to have any overhead at runtime. And so if you want to translate your custom format calls into standard ones at compile time, there is a compile time switch that you can activate, provided that everything in your format table is defined at compile time. In such a case, you also have an additional macro which is called in-format table, and you probably also can guess pretty easily what it does. It does exactly the same for a format table that what an in-read table would do or in-package would do for a package, for instance. If you want this compile time behavior, though, what you need to do is focus actually depends on an extension to ASDF, which is called ASDF FLV. FLV stands for file local variables, and it turns the format table, the current format table global variable, into a file local variable, just like package star is in the Common Lisp standard. Okay. That's it. So it's the latest and also the first version is on GitHub now. It's probably going to be added in QuickLisp in the next release of QuickLisp. You can get it on GitHub already. And that's it. I hope you liked my red pandas. I think that's it for today.